everybody, this is for our senior design project, Spring 2020 SDSU. We are Team 49 GAPS, and we designed a garage assisted parking system that can be seen over there. We have a previous video that talks about how the garage works, and today we're going to talk about the Wi-Fi module that was intended to be implemented into the system, but unfortunately wasn't able to be. So we want to talk about why it proved to be pretty unreliable compared to just a button controlling the states of the motor, and why we were able to pull the motor up and down easier than this system. So let's go over the parts. We have an Arduino microcontroller, a couple resistors, a push button for the reset on the Wi-Fi chip, a 3.3 buck converter, an ESP8266 Wi-Fi chip, and the breakout board for it, a 5-volt stepper motor, and a ULN2003A motor driver board. And so basically, let's talk about the main issues that we were seeing. The first issue we encountered was connecting this chip. This chip proved to be pretty buggy, well, at least for us. It works pretty decent now, but when we were initially starting, it proved rather difficult. It's powered by 3.3 volts, so initially we took 3.3 volts from the microcontroller and connected it. It wasn't working, and we almost blew out that chip. We found out that actually, we didn't blow it out. We almost blew it out when we wanted to step down 5 volts using a voltage divider to power the 3.3 volts to here. But we used 3.3 volts initially and just didn't turn on. So we found out this thing actually requires a lot of current, and it peaks at like almost 240 milliamps. So we ended up buying a buck converter and taking 5 volts from the microcontroller and stepping it down to 3.3. And the logic TTL voltage is 5 on the microcontroller, so we for at least for the receive and transmit pins. So we needed to step that down with a voltage divider and send the RX signal to the TX signal of the Wi-Fi chip. So we also found that we designed the motor to be controlled with a state machine, and we think that the Wi-Fi chip also may not process the states fast enough, and that's also why it proves to be a little bit slower for the motor to turn compared to just a regular button controlling the states. So yeah, that's pretty much it. We had an issue since this is driving so much current and voltage. We needed to power the motor from an external power supply for 5 volts, and it pulls around 150 milliamps, maybe more, maybe less, depending on the motor. And then so this chip here connects to the Blink app, which is where we have our digital pin to turn off and on the motor. So we have the serial monitor. We are pinging at 12 milliseconds. Let's go ahead and turn this bad boy on. All right. So yeah, 150 milliamps, and the motor works. All right. Again, it just proved more unreliable than the button, just because sometimes this chip will disconnect from Wi-Fi, or sometimes it'll have a really hard time turning on. We think it could be these connections, could be that it's still not getting enough current that it actually needs. We tried doing flipping it around and using the power supply to power it, but it worked pretty much the same way. Still slow, still had difficulty turning on. So we think it's just this chip just happens to be a little bit cheaper Wi-Fi chip. But overall, it works, and our concept proved to be correct. Let's go ahead and stop it. Alright, good luck to all the senior design teams. Thanks, everybody.